In recent years, artificial intelligence has been creating a massive buzz around the world. Especially after ChatGPT, it's helping people write complex code in seconds, create articles and blog posts in minutes, and generate stunning visuals from just a few words. Want to know what AI really is? Curious how it works? Looking for a simple way to understand the fundamentals? You're in the right place. Hello, I'm Noro Chalise, a data scientist and author. I share my knowledge on Medium and now also through my website noroinsight.com. Here on YouTube, I'll be sharing what I learn, so we can learn and grow together. Feel free to connect with me on LinkedIn or through my website. Let's begin. Here's what we'll cover in this video. We'll start with a simple introduction to artificial intelligence and look at the different types of AI. Then we'll talk about how data is used in AI and the types of data you'll often work with. After that, we'll dive into machine learning and go over some common algorithms. You'll learn about the machine learning workflow and get a quick overview of deep learning and its main architectures. Next, we'll explore natural language processing, followed by computer vision and generative AI. We'll also look at large language models (LLM) and a smart method called retrieval augmented generation or RAG. Finally, we'll talk about some critical concerns in AI, what it means to use AI in the right way, what's coming next in the future of AI, and the skills and tools you'll need to get started. Artificial intelligence, or AI, means creating systems that can think and learn like humans. These systems can understand data, recognize patterns, and make decisions, sometimes even better and faster than people. AI can handle tasks that need human effort, like answering questions, spotting trends, or recommending products. It can also predict what's next so businesses can make smarter decisions. Behind the scenes, AI uses tools like machine learning and deep learning to power things like natural language processing, computer vision, and more. Let's understand how AI works in a very simple way. Imagine you're teaching a young child to recognize fruits. Step 1. Giving data. You show the child lots of pictures: apples, bananas, oranges. Each picture is a small piece of information. This is called data. The more pictures you show, the more the child starts to notice things. Step 2. Learning from examples. After seeing many fruits, the child begins to learn. They might notice that apples are round and red and bananas are long and yellow. This is called learning, finding patterns in what they see. AI learns the same way. It looks at many examples and slowly starts to understand patterns. Step 3. Making a decision. Now you show the child a new fruit. They say, "That looks like an apple." They are using what they've learned to make a guess. AI does the same thing. After learning from data, it can give an answer or make a prediction. So, in simple words, AI collects information, learns from patterns, and then makes a decision, just like a child learning from examples. Let's talk about the three main types of AI. First, we have narrow AI, also called weak AI. It's designed for specific tasks like language translation, answering questions, spam filtering, or medical image analysis. Even powerful tools like ChatGPT, Gemini, or Claude are considered narrow AI because despite handling many requests, they still have clearly defined roles. Second, there's artificial general intelligence, or AGI. AGI would be capable of learning, reasoning, and understanding across any task or field, just like humans do. It could adapt to entirely new situations, solving problems even if they've never been seen before. AGI hasn't been achieved yet, but ongoing research is slowly moving in this direction. Third, we have superintelligent AI. This would surpass human intelligence, solving complex problems, creating new ideas, and making decisions even better than people. Right now, superintelligent AI remains theoretical, a possibility we might see in the future. Data is the fuel that powers AI. Just like our brain needs information to think and decide, AI systems need data to work. It can be organized like spreadsheets or unstructured like images, emails, or social media posts. But here's the key. The quality of data matters. If the data is messy, incomplete, or biased, the results won't be reliable. That's why you often hear, garbage in, garbage out. Once the data is ready, AI looks for patterns, trends, and insights. There are three main types of data in AI. Structured data is neatly organized. Like rows and columns in a spreadsheet, think of a customer list with names, emails, and phone numbers. It's easy for computers to read and process. Unstructured data has no clear format. This includes photos, audio, videos, or voice messages. It's full of value, but harder for machines to understand. Semi-structured data is somewhere in between. It has some structure, but it's more flexible. For example, a JSON file or HTML. Not a perfect table, but still organized enough for AI to work with. AI can handle all these types of data, but how well it performs depends on how well the data is prepared and managed. Before AI can learn from data, we need to clean and prepare it. This step is called data preprocessing, and it's super important. First, we clean the data. That means removing duplicates, handling missing values, fixing obvious errors. For example, if someone's age is listed as 150, we know something's wrong. Next, we transform the data so AI can understand it better. This could mean scaling numbers to the same range, converting yes and no into 1 south and 0 south. Finally, we do feature engineering. Here, we pick the most important info, or create new features that help AI learn, like combining height and weight. To make a new feature like BMI, good preprocessing sets the foundation for better results. It's like sharpening your tools before starting the job. Ever feel like YouTube, TikTok, or other social apps know exactly what you want to see? Sometimes even before you search for it. That's machine learning at work. It's a technique that lets computers learn from data, without needing detailed instructions for every task. Instead of telling the computer what to do, we give it examples and it finds patterns on its own. It's just like how we learn. The more we practice, the better we get. Machines improve the same way by analyzing more data. This helps AI make smart predictions and decisions like recommending videos or products, recognizing faces in photos, or spotting unusual activity in your bank account. There are 4 main types of machine learning, and each learns in its own way. First is supervised learning. It's like teaching by giving clear examples, like emails labeled as spam or not spam. The model learns from these labels to make predictions later. Second, we have unsupervised learning. Here, the data has no labels, just raw information. The model finds patterns by itself, like grouping customers who buy similar things. Third is semi-supervised learning. This type uses some labeled data and a lot of unlabeled data. The model first learns from the labeled examples, then gets better by studying the rest. It's great when labeling everything would cost too much or take too long. Finally, there's reinforcement learning. This model learns by trial and error, like training a dog. When it does something good, it gets a reward. If it makes a mistake, it gets a penalty, used in things like robotics and games. Supervised learning is like teaching a child with examples and answers. Take a look at the images on your screen. Let's say we show a child these pictures and tell them, this is a cat, this is a dog. With enough examples, they start to see the difference, even in new pictures. That's how supervised learning works. We train a model using labeled data where each input has the correct output. It learns patterns like how to recognize animals, predict house prices, or detect illness in medical scans. Once trained, the model can look at new data and make accurate predictions, just like the child recognizing a new animal. Unsupervised learning is when a model works with data that has no labels, meaning we don't give it any answers. Instead, the model explores the data by itself. It looks for patterns, similarities, or groups. This is useful for tasks like finding groups of customers who buy similar things, or detecting unusual activities in cybersecurity. Look at the image on your screen. The model sees different shapes: circles, rectangles, and triangles. Without labels, it groups similar shapes together, all on its own. This is how unsupervised learning discovers structure from unknown data. Semi-supervised learning is a mix of both supervised and unsupervised learning. Imagine a child learning to read. You show them a few flashcards with pictures and labels, like apple or dog. Then you give them more cards without labels. They use what they've learned to guess the rest. Now look at the image on your screen. We've labeled a few cats and a few dogs. But some animals, like monkeys, have no labels. The model uses the labeled examples to understand the patterns, then learns to recognize the monkey on its own. That's the power of semi-supervised learning. It's useful in areas like medical research, speech recognition, where labeling all the data is costly or hard to scale. Reinforcement learning is like how a child learns through experience, by trying, failing, and improving. Imagine a kid learning to ride a bicycle. They might fall a few times, but with each try, they figure out what works. They're rewarded when they ride successfully, and they adjust to avoid falling again. In machine learning, it's the same. The model interacts with its environment, tries different actions, and learns from the feedback, getting rewards for good outcomes and penalties for mistakes used in robotics, gaming, self-driving cars, stock trading. Machine learning algorithms are like step-by-step rules that help models learn from data and make predictions. In this video, we'll give you a quick overview, just the big picture without going into the technical details. We'll explore each one in more depth in upcoming videos. Let's start with supervised learning. This type uses labeled data where the correct answers are already known. Common algorithms include linear regression and decision trees, along with others like random forests, SVM, and logistic regression. These are often used for prediction and classification tasks. Unsupervised learning. Here, the data has no labels, and the model finds patterns by itself. Examples include k-means clustering and PCA, as well as others like DB-scan and hierarchical clustering. It's useful for grouping, segmenting, or data compression. Reinforcement learning. This is about learning by trial and error, with rewards and penalties. Key methods include Q-learning and deep Q networks, and others like policy gradients or actor-critic methods. It's often used in robotics, games, and self-learning systems. Let's walk through a complete machine learning workflow. The step-by-step process used to build, train, and use a model effectively. Step 1. Collect and prepare data. Everything starts with data. We gather it from sources like databases, files, APIs, or sensors. Then we clean it, remove duplicates, fix missing values, correct errors. Step 2. Feature selection and engineering. Not all data is useful in raw form. We choose the most relevant features or create new ones that represent the problem better. Step 3. Split the data. We split data into training and testing sets. The model learns from training data and is evaluated on the test set to check how well it generalizes. Step 4. Train the model. Now we feed the training data into an algorithm. It finds patterns, adjusts settings, and learns from the data. Deep learning is a branch of ML that works using artificial neural networks, systems inspired by the human brain. It uses many layers of neurons to process information, which allows it to handle complex data like images, audio, and language. Thanks to deep learning, AI can recognize faces, drive cars, understand speech, even generate human-like text, as we see in tools like ChatGPT. Let's look at the most common types of deep learning models. 1. Artificial neural networks. The basic type used for classification and prediction. Great for simpler datasets. 2. Convolutional neural networks. Built to work with visual data, especially images, used in facial recognition, object detection, and medical scans. 3. Recurrent neural networks designed for sequential data like text or speech, used in language models, voice assistants, and forecasting. 4. Transformers revolutionized NLP. They understand and generate human language, powering models like ChatGPT, Gemini, and Claude. 5. Specialized models, like GANs, which generate images, and autoencoders for compression and denoising. Each model type is made for a specific kind of problem, and deep learning keeps evolving. Artificial neural networks, or ANN, are the foundation of deep learning. They're inspired by how neurons in our brain connect. Data flows through the input layer, hidden layers for processing, and the output layer for the result, used for tasks like email classification, sales prediction, and other data-driven decisions. CNN are made for working with images and videos. They scan small parts of the image with filters to detect edges, textures, and shapes. Pooling layers help reduce size while keeping important features. Used in facial recognition, object detection, medical image analysis, even self-driving cars. RNN are designed for sequences like text, speech, or time series data. What makes RNN special is their memory. They remember previous inputs, which helps predict what comes next. Used in voice recognition, language translation, text generation. Transformers handle language more effectively than older models. Unlike RNN that read word by word, transformers look at the whole sentence at once. They use something called attention to figure out which words are most important in context. Introduced by Google in 2017 in the paper "Attention is All You Need." Transformers changed the field of NLP. Today's top models: ChatGPT, Gemini, Claude, Mistral are all built on this architecture. NLP stands for Natural Language Processing. It helps computers work with human language, like reading, understanding, and responding to text or speech. A part of NLP is called NLU, which means Natural Language Understanding. Here's a simple way to see the difference. NLP looks at the words. NLU tries to understand the meaning. For example, if you say, "I'm starving," NLP sees those exact words. NLU understands that you might want to order food. Together, NLP and NLU power tools like ChatGPT, Google Translate, and chatbots. Here are some core NLP techniques. Tokenization. This means breaking text into smaller parts, like words or sentences, so the computer can understand the structure, named entity recognition (NER). This technique helps find important information in text, like names of people, places, or dates. Sentiment analysis. This tells whether a sentence sounds positive, negative, or neutral, or what kind of emotion or opinion is being expressed. Part of speech tagging. This means figuring out the role of each word, like whether it's a noun, a verb, or an adjective. Machine translation. This helps translate text from one language to another, like turning English into French or Spanish. These techniques power many apps you use every day, like chatbots, voice assistants, and translation tools. Computer vision helps machines see like humans by analyzing images and videos. It uses deep learning, especially CNN, to detect and understand visual data. Used in self-driving cars, medical scans, security systems, face recognition. Generative AI is a type of artificial intelligence that can create content on its own, like text, images, music, or even videos. It learns from a large amount of existing data and then uses that knowledge to produce something new. For example, it can write messages, stories, or articles like ChatGPT, Claude, or Gemini. It can turn text prompts into images using tools like DALL-E, Midjourney, or Stable Diffusion. Generative AI is used in many areas like writing, design, coding, video editing, and filmmaking. Large language models, or LLM, are some of the most powerful and popular tools in AI today. They're trained on huge amounts of text data from books, websites, articles, and conversations. This helps them understand human language and generate responses that sound natural and human-like. LLM use a special method called the transformer architecture, which helps them understand context, predict what comes next, and respond in a smart and meaningful way. Some well-known LLM include GPT for ChatGPT, Gemini, Claude, Llama, and Mistral. They are used in tools like chatbots, AI assistants, and smart search engines. But some newer models go even further. They are called multimodal models because they can work with more than just text. These models are trained to understand and generate text, images, audio, and even video. For example, you can give them a picture and ask questions about it, or ask them to create an image or video from a text prompt. Models like GPT-4o, Gemini, and Claude 3 are great examples of multimodal AI. They combine language understanding with visual and audio abilities, making them even more powerful and versatile. Large language models, or LLMs, are used in many smart ways to make our lives easier. Conversational AI. LLM is power chatbots and virtual assistants, like ChatGPT, Gemini, and Claude, which can chat, answer questions, and assist in real time. Content creation and summarization. They help write and summarize text, translate between languages, and even generate code or creative content. For example, tools like Notion AI or WriteSonic help with writing, while GitHub Copilot helps developers write code faster. Research and productivity. LLM can answer complex questions and support research tasks. For example, Perplexity AI helps you search and get direct answers from trusted sources faster than traditional search engines. Customer support. Companies use LLM to automate replies, reduce wait times, and improve support. For example, Zendesk AI and Intercom use LLM to chat with customers instantly and solve common problems. Education and tutoring. LLM can explain difficult topics in simple terms and even generate quizzes or notes. Apps like KhanMeGo from Khan Academy use LLM to tutor students in a personalized way. Search enhancement. LLM makes search smarter by understanding what you really mean, not just the words you type. Tools like U.com and Perplexity AI use LLM to give you better, more relevant results. LLM are now part of many tools we use every day, helping with learning, working, creating, and more. RAG stands for Retrieval Augmented Generation. It helps AI give answers that are more accurate, up-to-date, and reliable. Here's a simple example. Let's say you ask an AI, "Can I go hiking tomorrow?" A regular AI might give you a general response based on old weather data, or it might not know your location or current conditions. But with RAG, the AI can search live weather updates or air quality reports, then give you a clear answer like, "The weather looks good tomorrow, but the air quality is low. It's better to wait." This way, RAG helps AI respond with real-time, helpful information, not just guesses from old data. Let's look at some important ethical concerns in AI. First, deepfakes. These are fake videos or voices that look and sound real. They can be used to trick people or cause harm to someone's image or reputation. Next, misinformation. AI can create content that looks true, but shares wrong or made-up information. This can confuse people or spread false news. And finally, copyright and ownership. It learns from things made by people, like drawings, music, or writing. This brings up questions like, is it fair to use work made by someone else? Who owns what the AI creates? These are real concerns we need to think about as AI becomes a bigger part of our lives. Artificial intelligence is powerful, but with that power comes responsibility. Responsible use means building systems that are fair to all users, transparent about how decisions are made, and accountable when something goes wrong. We also need to protect people's privacy, make sure sensitive data isn't misused, and prevent tools from being tricked or used to cause harm. If these systems aren't designed carefully, they can spread bias, share false information, or even be used in harmful ways. That's why it's important to focus not just on what the technology can do, but on how we use it. Let's look at some exciting trends shaping the future of AI. Edge AI. This means running AI directly on devices like smartphones, smartwatches, or home gadgets instead of relying on cloud servers. It makes things faster and keeps your data more private. Quantum AI. This combines AI with quantum computing, a new type of computer that could solve really complex problems that today's computers can't handle. Green AI. This is about making AI more energy efficient, using less power, reducing carbon footprints, and building smarter systems that are better for the planet. These trends show where AI is going, toward being faster, smarter, and more sustainable. If you want to get started with AI, here are some core skills to focus on: programming and libraries. Start with Python. It's the most popular language in AI. Then learn helpful tools like NumPy, Pandas, and Polars for working with data. Use Matplotlib, Seaborn, or Plotly to make charts and graphs. And for building AI models, get familiar with scikit-learn, TensorFlow, or PyTorch. Data and preprocessing, learn SQL to work with databases and pull out useful information. You'll also need to know how to clean and prepare data, using tools like Pandas or OpenCV if you're working with images. Machine learning basics. Understand the key algorithms like regression, clustering, and decision trees, and learn how to test and improve your models so they perform better in real situations. With these skills, you'll have a strong foundation to start exploring and building with AI. Once you've built a strong foundation, you can start exploring advanced topics and real-world deployment, deep learning, and specializations. You'll dive into neural networks, including models like CNN for images, RNN for sequences, and transformers for powerful language models. You'll also explore areas like natural language processing using tools like GPT and other LLM, and computer vision, which helps machines understand images and video. MLOps and deployment. It's not just about building models. You also need to know how to deploy them. You can use tools like Flask, FastAPI, or Streamlit to turn your models into real applications. And for scalability, you'll work with cloud platforms like Oz, Google Cloud, or Azure. Responsibility. Artificial intelligence is powerful, but with that power comes responsibility. Responsible use means building systems that are fair to all users, transparent about how decisions are made, and accountable when something goes wrong. Thank you for joining me on this beginner's journey into AI. This is my first video, so I would truly appreciate your feedback. Let me know what helped and what you'd like to see next. For more guides and learning resources, visit neuroinsight.com. If you found this video helpful, like, subscribe, and feel free to leave a comment with your thoughts or questions. Congratulations on completing your first step into the world of AI. Let's keep learning and building together.